Hey guys, today on Dr. Griggs, let's get loud. This subscribe. I know that what we're going to be doing is we're going to be modifying these Fisher ST-830 speakers. It's got a 15-inch low driver, about a 4-inch mid, and I think a 2-inch tweeter. And the problem is these speakers are very boomy. They're not what I would say is a full spectrum speaker. And what I mean by that is the frequency response of this speaker is lacking. It does not push out what it needs to push out as far as a full range in the high, and the low drivers are very powerful and they overpower the tweeter drivers dramatically. And anything that you're listening to, you can tell. And we're going to modify that today in a cheap and unique way. This is just something for if you guys want to, if you got a set of speakers that they don't sound right, they don't give you that sound, that crisp highs that you want, like these, they just no. This is a way to cheaply modify them and get the sound that you're looking for. So let's look at some of the specs first before we start messing with stuff so that we know exactly what we're dealing with. Okay, so let's take a second to understand how a speaker, an amp, and EQ, how all these components work together. What is frequency response? What is ohms? What is this? What is that? How does all this work? So that you understand kind of how to get this. First, let's understand the basis of it. A speaker vibrates, and it resonates, or not resonates, but vibrates at certain frequencies. The lower the frequency, the slower the speaker vibrates. Now, whether it's, I don't care, a car or a home theater system or any kind of theater system, it's AC voltage that is going to the speaker, because in order for that speaker to work correctly, it has to be able to vibrate. So this cone right here, this is the cone, this is the dust cover, this is called the suspension. The piece underneath here is called the spider. Underneath, inside this, we have the voice coil, and of course we have the basket or the cage, and then we have the magnet. Now, for the demonstration purposes here, this is a HX2 DVC punch. It's one of the old school. It's a 1,000 watt RMS dual voice coil. Okay, so for each voice coil can take 1,000 watts. So this is one of my more favorite speakers that I have. I've broken windows with these speakers. But so the speaker has to oscillate this way and this way. The lower the frequency, the slower the speaker does that, and the more bass you get. This is more of a mid-range driver. This is a 100 watt mid-range driver right here. And we can kind of move this. You can kind of understand how it works. It sits on the suspension and the spider, and that allows the speaker to move. So you want to separate these channels in order to hear them specifically, because there's certain rules here. Number one, because it's AC current, it can only move in one direction at any given time, period. Sometimes you'll hear the word peak, and that refers to the amp peaking or clipping. And what that means is the AC voltage that's coming out of the amp and going to the speaker has, on the sound wave, if you look at a sound wave, it comes up and it flattens out. And when it flattens out, it turns to DC voltage. And when it turns to DC voltage, the speaker tries to move in two ways at one time, and of course it can't do that. That's a good way to blow speakers. So all you car audio guys that are out there always blowing up your speakers, your subs in your trunk, it's because you're peaking your amps. And when you clip your amps, you're sending DC voltage, and it's going to destroy the voice coil, and you're going to blow your speakers. There's a correct way to do this. There's a way to check this to make sure that your amp does not ever peak or clip. You have to buy a device and you have to hook it up and make sure that you're putting out the correct wattage to the correct speaker at the right ohms, and you're not clipping your amp. You also have to make sure your head unit's not clipping. So all you guys that are blowing your speakers, that's why. You're turning your amps up so much that you're sending a dirty signal to the speaker, and it can't. I don't care. You're going to have the nicest speaker in the world. You will mess it up. Rule number 2. Because the speaker can only move in one direction at a time, you don't want to try to push all the frequency range between, you want to separate it. You don't want to push it between one speaker. You want to separate it between multiple speakers. For instance, this is an old Rockford Fosgate crossover. And what a crossover does is it takes the input that has the full range and it separates it. Okay, so this is called the high pass, which you would hook your tweeter up to. And then this is called the low pass, which you jump from here to here, and it interacts with the ground of the, it interacts with one of the inputs from the tweeter and here, and it runs them in series inside. And then here's this is a bypass, which just cuts the low frequency, or the high frequency. So what you want to do is you want to take your tweeter, hook it from here to here, positive, negative, mid-range, positive, negative, and the low end right here. And what this does is it separates the frequencies and breaks them down. So for instance, let's look at this right here. This is a 3-way high fidelity speaker system. Now this speaker comes in, it's a good matchup for the lower end because it almost gets up to about 100 decibels, okay? And this one, unlike our low speakers, does not lack in the low end. See how it goes all the way up to 20 and it stays flat? That means it curves after that. But nothing after that matters because we cannot hear above that, which I'll get into in just a second when we look at the EQ. So what the crossover does is it goes from here to about right here, this fat line right here, and it sends those signals to the lower end, okay? And then it takes from about here to maybe about 2K, well, no, 5K, somewhere in there, okay, right here, and it sends it to the mid-range speaker. And then it takes everything above that and sends it here. And the reason that you want to do that is because this speaker is bigger, it's made for lower frequencies, and this speaker is smaller, it's made for higher frequencies. True. But the main reason that you want to separate these is because the high end, will always vibrate faster than low end. Remember that a speaker makes sound by vibrating, just like our ears pick up that vibration and we interpret it as sound. So if this is going at a low frequency and it's vibrating, it's going to be hard for this speaker to vibrate very fast to make the higher frequencies. So you want to separate it so that way the speakers are each individually doing their own set of frequencies. That is the biggest key, one of the biggest keys for clarity, especially in car audio, because most home theater or home systems, they come like this. They have a 3-way system, something like that. Or if you have one of the newer systems, you end up having something like this right here. Okay, so this is a Yamaha, what is this? This is a Yamaha NX-220P, okay? This is a 6 ohm 100-watt speaker, and what it has inside is 2 little drivers. This does mid and highs, and what you would have to have with this is a subwoofer to accommodate and fill in the low end, because of course these can't make that low end. So this really doesn't separate signals, and because of that, this can only get so loud. It can only reproduce sounds at a certain decibel level before it starts to distort, okay? So it's very important. That's rule number 2. Separate your frequencies, especially in a car. One of the biggest things that I always tell people about setting up their car system is you have a sub. You do not need bass going to the door speakers or dash speakers or deck speakers in the back. Set your high pass filters, the HPF. You have to set that. If you set that, it cuts all the low end from the door speakers. It's basically like taking this and going like this, except it just cuts it. The whole low end The whole low end gets cut off of those speakers, and they don't have to reproduce that noise, so they can get a lot louder, a lot clearer, because they're not trying to reproduce the full spectrum, and it helps. Okay, so that's rule number 3, actually, is high pass cutoff. Okay? So, human hearing goes from 20,000 hertz to, 20 hertz to 20,000 hertz. Okay? Here I have a 12-band EQ. These two center ones we're going to ignore because this is balanced. This is left and right. Okay? So let's set these all equal real quick. Now, it starts at 36 hertz and goes all the way up to 16 hertz. This EQ is decent for any kind of home theater system. You know, you're listening to tapes, vinyls, CDs, whatnot. This will do you good because it gives you a decent, it's a 12-band spectrum here. I do like to see a little bit on the lower end, but most of the stuff that I listen to, I like to have a lower end and a higher end. But this is an older one. But this one is cool because it has this expander, which takes the two channels, and it makes it sound a lot wider. But so here we have our low-end channels right here, our frequencies, okay? And then we start to move up into our mid-range, which is right here. It kind of, mid-range splits kind of right in here. And then here's our high-end, okay? So we're about 5.2, you know, that's about 4,000. Right after 4,000, it's like high-mids, somewhere in there. And then we have our high-end right here, because you've got low-mid, mid, high-mid, high. So the higher the frequency you go up, the faster the speaker vibrates. And the faster it vibrates, the higher tone it makes. And of course, that's when we hear our higher stuff, like a maraca or cymbals on a drum, the high end of a guitar and stuff like that. Most of the guitars go through mid-range. Most guitars are right in here, especially around 4,000 hertz. 4,000 hertz is a huge mid-range deal, high-mid thing. It is probably the most detrimental frequency in the high mid range, especially because if not set right, if you're ever listening to something and it's hurting your ears, it's about 4,000 hertz. That's what's actually hurting your ears. As we can see on this is a Yamaha 5410 guitar amp. We have a BC Richmond here. Okay. As we can see on this, if we look right here on our frequency response, we can see that this peaks, right? Actually, just at about 4,000 almost. That's because that's the biggest response for a, you know, that's what you want. You want something around this range right here, because this is where, from here to like here, and a little bit further up, depending on how far you get to it, not any further than that, is the range that goes. So, for a guitar amp, something like that, we would only have a frequency response about this. Now, here's what the frequency response is so that you understand this chart. Oh, here, this one's not upside down. Let's see if I can get up in there. So what the frequency response is when the speaker is being made, they test the speakers, okay? Now, they know what they're building, and they've already tested them, and they know how they work, and they know what they put out. What this chart is, and frequency response means, is these are the frequencies that this speaker responds to. These are the frequencies that this speaker is made to reproduce, and it will do it in this decibel level, depending on the different frequencies. And this chart here, our frequency response chart, charts the speaker so that we can understand, we can know what that speaker is capable of reproducing. Is it a mid-range speaker? Is it a tweeter for high-end? Is it a subwoofer for low-end? Is it a mid-range? Whatever have you. So that we can look at these charts and we can see exactly what that speaker is made to reproduce. And depending on what that chart tells us, we can then decide the best thing to use that speaker for, or what it's supposed to be used for, or if we have to replace a speaker. Like, I know for a fact, this is a 1978 G5410. I can't replace these speakers. If these speakers were to ever blow, I couldn't go to Yamaha and say, hey, I need these speakers. they would tell me that they don't manufacture them anymore and they don't offer replacements. So what I would have to do is I would have to get a recone kit at that point, 2 options, a recone kit and rebuild this speaker, or I would have to just replace the entire speaker. Now, let's talk about ohms, because now we know about frequency response. Okay, I want to set it on the suspension. So this is a dual 4 ohm speaker, okay? The reason that it's dual is because it's a DVC. It has 1 voice coil here and 1 voice coil here. It literally has 2 voice coils in it, not just 1. And we can kind of see what a voice coil looks like. I have 2 speakers here taken apart. They're behind the grate. The suspension is gone on this one, but you can see the voice coil right there. This one, the cone is gone. You can see the spider and the voice coil there in the leads. Let's see if I can kind of... There you go. So the voice coil, what it is, if you look down in there, you'll see the voice coil itself is a round cylinder that has coils wrapped around it. And those coils sit within the magnet. And just like an electric motor, when energy passes through those coils, it causes a magnetic field and causes it to push the cone out or suck the cone in. That's how the speaker vibrates. You see the 2 leads right there and there that come off the cone and go up to the terminals where they're supposed to hook up to the wires. Now these speakers grenaded on me, and I'm currently in the process of rebuilding them. I'm just waiting on the recone kits, which I'll do a video on later. So what the ohm rating is on a speaker is how much resistance that speaker puts on the load of the receiver or the amp or the input of the speaker. So if I was to take a voltmeter and go from here to here, nope, because I've got it wired 1 ohm. If I take it and go from here to here, I would get 4 ohms. Here to here is 4 ohms. These are ran in series because I have them running on a 1 ohm setup on an amp. But basically, if you know anything about resistance, that's what this is. The ohm rating tells you how much resistance, how much resistance, I was trying to think of a better word, that the speaker puts on the system. Okay? So I kind of hope that helps y'all understand a little bit better about speakers. And oh, there's one more thing. Polarity. This is important, especially if you have stuff like this where you have speakers stacked all the way to the ceiling. That matters. And it's something like this where you have 4 10s in one case, or if you have subs. What polarity is, I'll show you on this speaker. Let's see, there it is. See if the camera will focus. While it's focusing, I'll go ahead and talk. This is the positive lead, and this is the negative lead. I'm trying to see if I can get it to where you can... No, it won't let me show you. I'll just show you with this. So here we have the positive lead, here we have the negative lead. Now, some speakers, like JBL's, they reverse polarity. What that basically means is, if I put a positive here and a negative here, this speaker will push out. If I put a positive here and a negative here, this speaker will push in. Okay? You want to make sure that you match up your polarities on all your speakers. That is a big factor. Because if you have, say that I have these 2 speakers, okay? And they're moving, they're vibrating to the music and the sound. If they're moving opposite of one another, it will dramatically affect the quality of the sound. And it won't push the air as unified across the board, especially with something like this. Okay, this is a 15, that's a 12, that's a 12. And if I take these speakers and they're not all moving at the same, they're not polarity correctly and they're not moving the same, what will happen is my low end, my mid range, it will be affected dramatically. It will be cut in less than half because the speakers are fighting each other. So polarity is positive and negative. Make sure you hook them up correctly. It's the exact same concept as an electric motor. If you had an electric motor and you hook up a battery to that electric motor one way, it spins one way. You hook it up the other way, it spins the opposite way. Speakers are the exact same concept as an electric motor. They are. It's coil wrapped around, and it creates a magnetic field that reacts with a magnet, and it causes it to spin or move in this case of a speaker. So, hope that helps y'all out. And if you have any questions, comment below. Let's get to work on our speaker. Okay, so let's look at this for a minute. Now, this frequency response on the low end picks up at 20. It peaks at 50. We're okay here, but here's where we have the issue. So around maybe, I don't know, maybe 16,000, 17,000, something like that, it just dramatically drops off. Now, if you're like me and you listen to a lot of different kind of music and you're an audiophile and you have to have that crisp, clear sound, this is a problem, because when you have like a lot of hi-hats, if you're listening to metal or if you're listening to like dubstep or chill step and stuff like that, and you want the really crisp, like this is not going to fly. This is not going to cut this. So we've got this speaker, RMS is at 100 watts. Its peak is 200 watts. Its crossover frequency is 1.5 to 6 kilohertz. So let's look at these. This is what I came up with. And you wouldn't believe, some of you might laugh, what these actually are. So I got these from Walmart. They are $7, where my Walmart is. Okay. And they're Power Acoustic NB-18. They're 200 watt max. They're 100 watt RMS right there. Okay. And they pick up from 5 and they go all the way up to 25,000. Now these are 4 ohm, which we'll discuss in that. How to hook these up so that it's going to not hurt anything. And they come with a surface and an angle mount. Now they have a SPL of 97 decibels. This speaker has a max of 100. Let's see if we can get this camera to focus here. There you go. This has a max SPL of 100. So that's going to work out fine. Our frequency response is perfect because it goes from 5 kilohertz to 25 kilohertz. Or 25,000. But if we look at our graph here, we pick up just before 3.5, so probably about 3.2 maybe, somewhere in there, 3.1. And it's got a pretty obtuse curve on it, but that's for a reason. These are neodymium-powered tweeters, and they have a very jagged response. They've also got built-in crossovers, which also has a very hardcore effect on this. But you can see here, we peak at about 10, and we cut off right before 25,000. But we'll still catch it. But that's fine because that's above our hearing. We only hear from 20 to 20,000. So these actually spec out perfect because if we look at it, we're going to be picking up right about here. So where this is right here, we're going to be picking up here. And we're going to be pushing it all the way past this graph. And this is actually going to work very well. I'm guessing that adding these tweeters to this speaker is going to make it sound amazing. Now, on the factory tweeter of this speaker, we have a couple of components here. So we've got the built-in crossover that's inside this speaker. And what that's going to do is it's going to come up with the wire, because that's how they used to do it too, is they'll come up with the wire, there'll be a capacitor, and there'll be a resistor in between this speaker and the input jack on it. So what we want to do is we want to take our tweeter here, this is it, okay? We want to take our tweeter and we want to wire it straight to the ground of this tweeter, but we don't want it to be putting out the exact same frequencies as this tweeter because this has a built-in crossover. This will control itself. We want to run it almost directly from the input, but not quite. We want to run it through the capacitor and not the resistor, because if we don't run it through the capacitor, it will dramatically overpower this. But if we run it through the resistor, or if we run it through the resistor, then it'll cut the frequency response of this probably in about half. It'll probably cut out here, and it won't pick up probably until about 5 or maybe even lower than that. So I'm going to take these 4 screws out, and we're going to go ahead and pop this tweeter out, and I'll show you the resistor and the capacitor, and we can go from there. Okay, so here's our inline resistor. You can see it comes off the tweeter, and it's a 2.2 thousand ohm 5-watt resistor. Now, I don't know. Yeah, you can kind of see it. There's the capacitor down in there, but I really can't pull it up any further. Let's see if I can read. I have no clue what this is going to be. It looks to be... I can't even read it. It's a 71 watt. It's a 1.5 microfarad. Okay, so we got a 1.5 microfarad, 71 watt capacitor right there, and then our resistor. So what we want to do is we want to hook it up to here, and we want to hook it up to here. So what I'm going to do is I'm going to do 2 things. Number 1, I'm going to hook this up to here and this up to here. Actually, and I've already done that. No, I'm sorry. I was going to say I'm going to make the hole right here for our base to screw in, because this tweeter came with a pop-on base. So we're going to install this. Now, because we are going after the capacitor and before the resistor, the 4 ohms deal, because we're going to talk about that later, the 4 ohms deal is not something that I can too much control. Unfortunately, the truth of the matter is these are car audio tweeters, so they're going to be 4 ohm, number 1. And number 2, this is a 8 ohm speaker. So being just a tweeter and going here to here, again, will balance this out. We should have a very equal equilibrium between these 2 right here, the neodymium and the regular tweeter, the factory tweeter that was in the speaker. So not too much that I can do about that, but I've kind of done the math between this speaker and this speaker and the resistor and the capacitor and what my receiver puts out and the frequency response here, the frequency response here. I've kind of done all the math out, and I think it's going to be absolutely on point. So now all I'm going to do is I'm going to take this, and this pops on here just like so. Now you can, if you want, drill a hole through and run your wire in through this. I just don't, I don't care. It's not a big deal for me. These are my personal speakers that, you know, I'm probably going to end up blowing up and rebuilding in a few years anyway. We've had these things. My dad's had these my whole life, so they're pretty good speakers. But if I mess them up, I'm not too worried about it, because I'll just rebuild them and make them even better. So you can either wrap the wire around the connector and solder it here, or you can put the wire in here and solder it, or you can undo this connector, take a male connector that goes into this female connector, and hook the ground wire from it onto that, and then hook another male connector on it, or female connector, so that you can plug it back into the speaker. You know, you can get as nice as you want with it. For me, again, it's not that big a deal. I know that it's going to be okay. So what I'm doing is wrapping the positive wire around the lead before the resistor, after the capacitor, and the female terminal on the ground wire. I'm going to solder these 2 up just a little bit, and I'm going to throw this tweeter back in the cabinet, and then I'm going to take this and angle it right here. You can see I've just screw the speaker on, it'll hold the wire, it'll be fine. And then we'll come back and we'll test it and we'll see how. Alright, so here we are, all the way installed, and they sound amazing. Just unbelievable. The range and the frequency response is absolutely spot on. The factory driver picks up the low end of the high frequencies There is such a thing. So it picks up like right in here. And where this drops off, this picks up just before and fills. And you can literally cover this up and then cover this up. And they're the exact same decibel output. So one doesn't overpower the other, but they are covering different frequencies. So what you have now is the high end. One does not overpower the other. And I think that that's due to the fact that the frequency response, or not the frequency response, the ohms, this is 4 ohm, this is 8 ohm, but the SPL, the decibel response, is a lot higher on this than this. And because this is 4, this is 8, this has a higher SPL than this, it balances out. It's flawless. It's almost like they were made for each other. And you can cover these up, and if you're standing back and you cover this up, you just, that low, that high end is just gone. You uncover it and it feels absolutely perfect. So we just took this speaker for $7 and just added this quick modification, and it makes so much of a difference. It's unbelievable. So now all I got to do is glue my cone cover back on because it came off from me rocking out earlier. Glue is kind of old. Get that back on there, put the cover back on, and do the other one, and we're ready to go. See, we're getting stuff off this song up to 16,000 at least, because that's as far as this spectrum analyzer equalizer goes. I couldn't be more happy with that. I mean, it's just absolutely perfect. It's flawless. So, again, cheap way just to do a little upgrade, just to have a little fun. Yeah, it may not be the most accurate and correct thing to do, but I like modifying things my way to work the way that I want them to. So, I hope y'all enjoyed this video. I hope it helps you out if you've got a set of old speakers, or you know, something in your car you want to do, or this or that. Just make sure you do the proper math. Make sure you hook it up right, and you know, don't be doing stupid stuff. So, thanks for watching Dr. Griggs. Subscribe, comment, let me know what you think. Even if you think it's a stupid idea, don't cur. And y'all take care. Wonder what it's going to be next.